You are standing in your backyard. The grass is, perfectly green. The sun is shining. Maybe you have a barbecue going.
Yeah, the classic picture of domestic tranquility.
Right, exactly. But you are completely unaware that just a few feet beneath your lawn, there is a massive, living, actively functioning biological reactor.
And it is secretly dictating the health, the safety, and honestly, the financial security of your entire home.
Yeah, it really is. And because it remains entirely out of sight, I mean, for most people, it's entirely out of mind.
Until it fails.
Right, until it fails. And when it does fail, the historical playbook has always been to, well, wage chemical warfare beneath the lawn, trying to bomb the problem into submission.
Which is pretty much exactly how you invite a multi-thousand-dollar disaster into your yard.
Yeah. So today we are doing a deep dive into this really fascinating stack of research. It details a massive evolution happening right now in home infrastructure.
A very necessary evolution, I might add.
Oh, absolutely. We are finally moving away from that scorched earth chemical approach toward these highly targeted biological solutions. Specifically, we're focusing on preventative regimens like SEPTIFIX.
Because understanding this hidden biology, it goes far beyond just simple plumbing. It's a fundamental shift in how we manage our immediate environment,
Right.
It's the difference between blindly hoping your home's waste system just miraculously holds up and actually actively managing a micro-ecosystem so that it performs seamlessly for decades.
Okay, let's unpack this. Because to really appreciate the solution here, we have to stop treating a septic system like a passive underground trash can.
Yeah, a lot of people just think it's a box that relies on gravity to separate the heavy solids from the clear liquid.
Right. And our listeners, you already know the basic mechanics of how a pipe flows into a box.
Yeah.
But the real story here is the microbiology. We really need to look at this system as an underground stomach.
I love that analogy.
Yeah, because it doesn't just hold waste, right?
And-
It actually has to metabolize it.
What's fascinating here is that the entire metabolism of your home relies on incredibly specific bacterial strains. I mean, think about it. Every single day, wastewater from sinks, toilets, showers.
A washing machine.
Exactly. All of it flows into that tank. And it's carrying a very complex mix of organic polymers.
So we're talking about what? Cellulose from toilet paper?
Cellulose, yeah. Plus proteins from food waste, complex lipids from soaps and fats, and the bacteria in that tank literally have to manufacture and secrete extracellular enzymes.
Extracellular enzymes, like they're building chemicals on the fly.
Exactly. Things like celluloses and lipases. They use these enzymes to cleave those complex molecules into simpler monomers.
So that they can actually absorb and digest them.
Right. Without those enzymes, the food is just too big for them to eat, structurally speaking.
So the bacteria are essentially running a highly specialized chemical disassembly plant down there.
That is exactly what it is. And when that bacterial population is thriving, the waste decomposes incredibly efficiently.
Which means the sludge layer at the bottom of the tank barely grows.
Yeah, it slows down dramatically. And the liquid flowing out to your drain field is relatively clear and processed.
So the stomach is digesting exactly as it should.
Right. The enzymes break the bonds, the bacteria consume the organic matter, and the whole system reaches this beautiful, steady biological equilibrium.
But wait, I have to push back on this historical context for a second.
Sure.
If this is a delicate biological reactor, if the entire success of the system depends on these living microorganisms doing all the heavy lifting, why were harsh chemicals marketed and used as the go-to solution for decades?
That's a great question.
I mean, why was our first instinct to pour caustic bleach or heavy solvents down the drain the second we saw a slowdown?
Honestly, because the chemical industry completely capitalized on the illusion of the quick fix.
The illusion.
Right. Think about the mindset of a homeowner who's suddenly facing a slow drain or worse, a foul odor in their bathroom.
Right. It induces total panic.
Complete panic. You just want it gone. And chemical-based treatments offer this incredibly seductive immediate visual result.
Because they just melt the clog.
Literally. A caustic drain cleaner, which is usually heavy in something like sodium hydroxide, it creates an intense exothermic reaction.
Meaning it generates heat.
Massive heat. Enough to literally melt a localized grease clog in the pipe leading to the tank. So the pipe clears, the water drains.
And the immediate problem just vanishes. You see the water go down, maybe the chemical smell masks the biological odor, and you just assume, hey, I've solved the problem.
Exactly. It's a very, very convincing magic trick.
But it's just a trick.
Yeah, because the trick relies on you completely ignoring the collateral damage happening underground.
Right.
When that heavy dose of sodium hydroxide or bleach or whatever solvent you used hits the main septic tank, it drastically alters the pH of the water.
And those specialized bacteria, the ones making the enzymes, they need a specific environment, right?
They require a very specific neutral pH window to survive. So a sudden spike in alkalinity or acidity doesn't just slow them down or inhibit them.
What does it do?
It chemically lyses their cell walls.
Oh, wow. So it literally tears the bacteria apart.
Tears them wide open. They're dead.
It's the equivalent of salting the earth in a garden just to get rid of a single weed.
Yeah.
Sure, the weed is gone, the pipe is clear, but now nothing will ever grow in that tank again.
And the long-term fallout of that salted earth is just catastrophic for a septic system.
Because the workforce is dead.
Exactly. With the bacterial workforce decimated, the enzymatic breakdown of the cellulose and the proteins just grinds to a complete halt.
Which means the waste just sits there. I mean, the toilet paper doesn't dissolve. The organic matter just piles up.
And the sludge layer accelerates rapidly. You're building up solids at an unnatural rate.
And I'd imagine things start to smell pretty bad at that point.
Oh, absolutely.
Yeah.
Because the main biological engine is stalled, the system just defaults to whatever minimal anaerobic decomposition can happen.
Okay.
And that minimal process produces heavy amounts of hydrogen sulfide gas.
Oh. And that is where you get those intense rotten egg odors that start wafting up from your yard or coming back up your drains.
Yep. The classic septic smell.
So we essentially paralyze the digestive tract of our own home. And then we force ourselves to call out those expensive pumping trucks year after year to physically suck out the unprocessed waste.
All because we wanted a localized pipe to clear 5 minutes faster?
It really is a spectacular failure of preventative maintenance. And that doesn't even touch on the ecological impact of all this.
Oh, not at all.
Because when those caustic chemicals don't break down, they get pushed out into the drain field, right?
Mm.
So they're slowly leaching industrial solvents into the surrounding soil and potentially right into the local groundwater.
Which is terrifying when you think about it on a neighborhood scale.
Yeah.
But honestly, the realization of that ecological and financial damage is exactly what is driving this current evolution in home maintenance.
Right, the shift away from chemicals.
Exactly. The modern approach treats the septic system not as this, mechanical problem to be dissolved, but as a living ecosystem to be cultivated.
Here's where it gets really interesting. If we lean into that medical analogy again, the old chemical method was basically like taking a massive broad-spectrum antibiotic.
Right.
It wipes out all of your natural gut flora, leaving you totally unable to digest your food.
Yeah.
But the modern pivot, utilizing biological treatments like SEPTIFIX, is like taking a highly targeted daily probiotic.
That's a perfect way to look at it.
It introduces specific, helpful bacteria designed to naturally digest human waste and that organic sludge. But, and I have to hypothesize here, a probiotic alone doesn't survive in a stagnant, highly toxic tank.
No, it doesn't.
Like, you can't just drop good bacteria into an overwhelmed system and expect them to thrive without some sort of catalyst.
You've hit on the exact mechanical hurdle of biological maintenance right there.
Okay.
See, a standard septic tank is naturally an anaerobic environment.
Meaning it operates completely without oxygen.
Correct. And anaerobic bacteria, the ones that live without oxygen, they are incredibly slow eaters.
Okay, so they're just sluggish.
Very sluggish. It takes them a long time to break down solids. And as we mentioned earlier, their byproduct is that foul-smelling hydrogen sulfide gas.
So if you just add more of these slow-eating anaerobic bacteria to a system that is already struggling or backing up, you aren't really changing the metabolic rate of the tank at all.
Precisely. To truly shift the efficiency of that reactor, you need to change the environment from anaerobic to aerobic.
The aerobic meaning with oxygen.
Exactly. Aerobic bacteria, the strains that utilize oxygen, they can process organic waste up to 20 times faster than the anaerobic strains.
Wait, really? 20 times faster?
Yes. It's a massive difference in metabolic speed. And even better, their byproducts are mostly just odorless carbon dioxide and water.
Oh, wow. So no rotten egg smell.
Exactly. So the engineering breakthrough with a product like SEPTIFIX isn't just the bacterial payload itself.
It's the oxygen.
Right, it's the delivery mechanism for that oxygen. It is an effervescent tablet engineered to react with the wastewater and steadily release nascent oxygen directly into the liquid column.
Okay, so the tablet basically acts like a bellows stoking a smoldering fire into a furnace.
That's great visual.
By slowly diffusing that oxygen throughout the water, it provides the exact electron acceptors those aerobic bacteria need to just hyperaccelerate their metabolism.
Yes. It fundamentally alters the biological carrying capacity of the tank.
The bacteria just wake up.
They wake up, their reproduction rates skyrocket, and
Yeah.
they begin aggressively cleaving those complex polymers we talked about. They chew through the toilet paper, the grease, and even the existing sludge layer in a fraction of the time it would normally take.
And because they are metabolizing the waste so aggressively, the root cause of the odors is just eliminated.
Right, because the waste never has a chance to stagnate and produce that hydrogen sulfide.
The efficiency here is just brilliant. And frankly, the simplicity of it,
Yeah.
just fletching a tablet once a month to deliver both the workforce and the catalyst, I think that's vital.
It's the only way it works long term.
Because, let's be honest,
Hmm.
preventative care only works if human beings actually adhere to it. If the maintenance routine requires, I don't know, measuring out complex biological powders every week or hiring an electrician to install mechanical aerators, the average busy homeowner is going to abandon it.
Friction is the enemy of maintenance.
Yeah.
By condensing the delivery of the oxygen and those aerobic strains into a single flushable solid, you remove the behavioral friction entirely.
Which means you actually do it.
And by doing it, you drastically lower the risk of a catastrophic system failure, which, in the context of a septic system, usually means avoiding the absolute nightmare scenario of a clogged drain field.
Right, because if unprocessed sludge makes it out of your primary tank and into the perforated pipes of your drain field in the yard,
It forms what's called a biomat. It's this thick, impermeable biological mat in the soil.
the biomat. And once that soil seals up, the water has nowhere to go but back into your house or just pooling on your lawn.
It's a total failure of the absorption field.
And the only fix for that is bringing in heavy machinery to excavate your entire yard and lay a brand new drain field. We're talking tens of thousands of dollars.
A massive financial hit. And one that is entirely preventable by simply keeping the primary tank's metabolism running high.
But, we do need to be realistic about human behavior here.
Always.
Even with a supercharged, highly oxygenated biological engine running in the tank, you can still overwhelm the system if you treat your plumbing like a garbage disposal. I mean, biology always has its upper limits.
It absolutely does. A highly efficient biological reactor still operates on the fundamental laws of physics and chemistry.
Right.
If you continually introduce non-biodegradable materials, or if you flood the system beyond its physical volumetric capacity, you will shatter that delicate equilibrium no matter how much oxygen is in there.
Which brings us to the physical reality of living with this infrastructure day to day. If this underground ecosystem is starting to fail, how does it actually communicate that to us?
There are definite warning signs.
Like, what are the mechanical symptoms we see inside the house before a total collapse?
The earliest indicators are usually hydrodynamic.
Okay, water flow.
You will notice slow drains. If the water is taking progressively longer to empty from your sinks or your showers, it means the biological breakdown in the tank is lagging.
So the solids are building up.
Right. The volume of solids is displacing the liquid, and it is physically reducing the flow rate of the entire closed system.
So what does this all mean for you when you hear that weird glug, glug, glug sound in the guest bathroom after you flush? You shouldn't just brush it off as a quirk of old plumbing.
Definitely not a quirk.
That sound is trapped air. When an organic blockage begins to form down the line because the biological processing is stalled, it restricts the venting,
Exactly. It creates a vacuum effect inside the pipe.
and the air has to escape somewhere, so it gets pulled backward, pushing up through the water trap in your toilet or your sink.
Yep.
So that gurgling is actually the mechanical symptom of a biological failure. It is literally your ecosystem gasping for air.
It's a great way to put it. Paying attention to those pressure differentials is crucial. But you also have to monitor the olfactory signs.
The smells.
Right. If you walk near your drain field in the backyard and catch that distinct sour septic odor, it means the untreated wastewater is sitting way too close to the surface.
The anaerobic bacteria are winning the race.
They're winning, and the system is backing up.
To prevent that from happening, everyday defense requires adopting a few, honestly, non-negotiable household habits. And the research we're looking at is incredibly explicit about what can and cannot enter this biological reactor.
Number one on that list, the notorious flushable wipes.
Oh man, The term flushable is a plumbing tragedy, isn't it?
It's a marketing term, not a scientific one. It simply means the wipe will physically make it through the curve of your toilet bowl.
It does not mean it will biodegrade.
Not at all. Those wipes are heavily reinforced with synthetic fibers.
Plastics, essentially.
Yes. And the cellulase enzymes produced by the bacteria, they are designed for organic plant fibers, like toilet paper. They cannot break down synthetic polymers.
So the wipes just sit in the tank.
They sit there, and they start weaving together with grease to form these massive, indestructible, suffocating rafts of sludge.
Wow. Which really highlights the danger of grease itself, too.
Grease is terrible for the tank.
Because when you wash cooking oils and fats down the sink, they undergo a process similar to saponification when they cool in the tank.
They harden into a solid block.
Right. They create a solid, impermeable layer on the surface of the wastewater that literally blocks oxygen transfer, completely suffocating the bacteria below. So you must keep grease, feminine hygiene products, and paper towels entirely out of the system.
And on top of what you flush, you must be highly strategic about your hydraulic load.
Your water usage.
Exactly. A septic tank requires a specific retention time, usually 24 to 48 hours, for the solids to settle and for the bacteria to actually have time to process the liquid.
So if you decide to do, say, 6 massive loads of laundry back-to-back on a Sunday afternoon,
You are blasting hundreds of gallons of water into the tank in a matter of hours.
you are drastically shortening that retention time.
They're ruining it. The sheer velocity and volume of that water creates intense turbulence inside the tank.
It stores everything out.
It stirs up the resting sludge at the bottom and flushes it straight out into the drain field before the bacteria ever have a chance to metabolize it.
You are hydraulically overloading the system.
Precisely. Pacing your water usage, spacing out your laundry, fixing running toilets immediately, it's just as important as managing the biological chemistry.
And even if you are doing everything right, if you are pacing your water, withholding the synthetic wipes, and utilizing a targeted oxygenating treatment like SEPTIFIX, you still need eyes on the physical hardware.
Yes, hardware fails eventually.
The concrete baffles, the inlet pipes, they can degrade over decades. So having a professional inspect the structural integrity of the tank every few years is really the final layer of defense.
If we connect this to the bigger picture, what we are really talking about here is moving from an adversarial relationship with our home infrastructure to a cooperative one.
Right.
When you synthesize mindful usage habits with advanced biological augmentation, you achieve this kind of household harmony.
It's true. You transition from a state of low-level anxiety, always wondering when a pipe will burst or a yard will flood, into a state of total control.
You stop fighting the natural processes of decomposition and you start leveraging them.
It is a really profound shift in how we view the footprint of our own homes. I mean, we are leaving behind that 20th century era of reactive, toxic chemical interventions.
Rightfully.
We recognize now that the quick fix of an industrial solvent is always, always a long-term trap.
Always.
By embracing these highly engineered, biology-based preventative solutions, we're doing so much more than just protecting our bank accounts from catastrophic repair bills.
Right. We are actively protecting the soil chemistry and the groundwater tables beneath our neighborhoods. It is the ultimate demonstration that aligning with the complex biology of the natural world is far more powerful and far more economically sound than trying to chemically overpower it.
Because the bacteria already know exactly how to process the waste?
Exactly. Our only responsibility is to stop poisoning their environment and start providing them with the oxygen and the tools they need to thrive.
Which brings us to a final thought, something to really chew on after we wrap up today's analysis.
Okay.
We spent this time exploring how our individual household waste systems demand a highly delicate living biological balance to function. If you poison the microbiome of that single tank, the whole localized ecosystem collapses.
Right.
So if that absolute reliance on a fragile biological equilibrium is true for a single isolated home,
Right.
how might this alter our perspective on the massive interconnected municipal waste and water systems that sustain entire metropolitan cities?
Wow.
If we've spent the last 50 years secretly destroying the curing capacity of our own backyards with this chemical quick fix mentality, are we treating our global water infrastructure with that exact same dangerous arrogance?
It's a sobering thought.
And if a targeted biological revolution just changing the oxygen bacterial dynamics can save a single household from a multi-thousand-dollar disaster, what would an engineered biological revolution look like on a citywide scale?
That is the pivotal question of modern infrastructure. It forces us to examine our massive macro-level environmental blind spots through the incredibly precise lens of microbiology.
It really does. So the next time you are standing on that perfect green lawn, flipping burgers and enjoying the sun, just remember, you aren't merely a homeowner holding a deed. You are the active custodian of a vast, invisible underground reactor.
Hmm.
Provide it with the right biology, protect its environment, and it will quietly, efficiently take care of you for decades to come. Thank you so much for joining us on this deep dive. Keep asking the hard questions, keep looking beneath the surface, and stay curious.